Alright, so we're trying to figure out what type of a sequence this is. One way to do that is to try subtraction. So do the second term minus the first, and you get negative 7. If you take negative 12 and subtract the second term, negative 5, you get negative 7. And then if you take negative 19 and subtract negative 12, you get negative 7. So since we get the same number each time, we call that a common difference. And so our common difference is negative 7. So if we went forward, we're adding negative 7 each time. So this is called an arithmetic sequence. To get the next term, we can add negative 7. So on number 3, to find the next term, let's take negative 19 and add negative 7 to that. And so you get negative 26. Now we want to write an equation for this sequence. For an arithmetic sequence, we can use a sub n equals a sub 1 plus n minus 1 times d, where d is the common difference, and a sub 1 is our first term. So the first term of the sequence is 2, and then our common difference here is negative 7. And so if it's short answer, you can leave it like that. If not, if it's a multiple choice, you may have to change it to a simpler version to find the choice that matches up. So let's distribute our negative 7. So we have 2 minus 7 and then negative 7 times negative 1 is positive 7. Now we can combine these like terms. I'll write them where they're next to each other. So we have negative 7n plus 2 plus 9 plus 2 plus 7. 2 plus 7 gives us 9. So we have a sub n equals negative 7n plus 9. And so that's what you can write for number 4 for the equation for the sequence. Either that, or again, if it's short answer, you could also say a sub n equals 2 plus n minus 1 times negative 7. So be comfortable in either form. Here the pattern is that we're multiplying by negative 2 each time. If you can't tell just by looking at it, take negative 10 divided by 5, get negative 2. Take 20 divided by negative 10, and you get negative 2. And take negative 40 divided by positive 20, we get negative 2. So our common ratio is negative 2, so that means it's a geometric sequence. So if you're multiplying by the same number each time, it's geometric. Anytime you're alternating signs on a geometric, then the common ratio has to be a negative. To find the next term, do negative 40 times the common ratio, which is negative 2, and we get positive 80 for our next term. To write the equation for the sequence, the equation for the arithmetic sequences, or for the geometric sequence, a sub n equals a sub 1 times r to the n minus 1 power. So we'll substitute into that. Our first term is 5, common ratio is negative 2, and then our exponent's n minus 1. Here we want to find the mean, median, mode, and range. So the mean is the average. Add them all up, divide by the number of numbers. So we have 2 5s, we have 3 6s, we have 2 7s, and we have 2 8s. So that's a total of 9 numbers. So we'll add up all those numbers and divide by the number of numbers. If you're doing it by hand, 10 plus 18 plus 14 plus 16. So you get 58 divided by 9, or 6 and 4/9. 6.4 repeating, if you change it to a decimal. So either way, mixed number or decimal, either of those is fine. Median is the middle number. So if we list out all of our numbers, so we have 2 5s, 3 6s, 2 7s, and 2 8s. You can kind of take one away from each side until you get to the center. If there's one number in the middle, it's the middle number, it's the median. If there's 2, then you'll add them up and divide by 2. So the medians are middle number here, which is 6, and then a mode is the one that occurs most often. There are 3 6s, there's no other number that occurs more, so that's the mode. And then the range, for the range you take the biggest minus the smallest. So 8 minus 5 gives us a range of 3. Here we're trying to figure out the probability that you do not get a nickel. Now let's see, we have 8 quarters, 5 dimes, and 3 nickels. We're giving them each of the same equally likely outcomes. So not nickels would include the dimes and the quarters. That's 8 plus 5, 13 out of a total of 16. So the probability of not getting a nickel would be 13 out of 16. Here we'll find the probability of choosing a red, and then probability of choosing a yellow after the red. Now notice that it's not replacement, so that means these are dependent events. You do have to consider what happened on the first one before determining the second probability. So we have 5 red, 3 green, 2 yellow, and 2 blue. So there's 5 red out of a total of 12 chips, and then there's, after you've chosen a red out, now there's only 4 reds left. So there's 2 yellows out of a total of 11. Multiply those together, you get 10 over 132. You can divide them both by 2, and so you get 5 over 66. Want to solve this equation? Subtract 9 from each side. So you get 2x squared equal to 64. To get rid of multiplying by 2, divide by 2. And so we have x squared equals 32. To get rid of squared, we'll square root. If we do square root on both sides, we've got to do positive or negative. $32 can be rewritten as 16 times 2, and the square root of 16 is 4. We're looking for those perfect square factors there. So we get positive or negative 4 root 2. Want to simplify this? The positive square root of 144, that's 12. If we saw something like this, then we'd have the negative square root of 100, which would be negative 10. Not part of this problem, but just another example, just to make sure that you know where the sign comes from. Just whatever's in front of that. So if you don't see a sign, it's just referring to the positive square root. We want to simplify this. Multiply the numbers in front of the square roots. Negative 5 times 3 is negative 15. And then square root of 20 times square root of 10 is square root of 200. For the square root of 200, we're looking for any perfect square factors. And so we can rewrite that as 100 times 2. Square root of 100 is 10. Negative 15 times 10 is negative 150. So we have negative 150 square root 2. Here we can rewrite square root of 54 as 9 times 6. Square root of 9 is 3. And now we can add and subtract from left to right. These are all like radicals. 5 root 6 minus 3 root 6 is 2 root 6. And then add the 7 root 6 and we get 9 root 6.